Sometime last year, someone said that by the time we're all arguing if we have AGI or not, that means we have AGI. Let's take a look at what people think about the new O3 model, whether or not it is AGI or not. And also, do you remember the Orion model that was supposed to be coming out? Sam Altman hinted at it being released this winter. Here's Sam Altman saying, "I love being home in the Midwest. The night sky is so beautiful. Excited for the winter constellations to rise soon. They are so great." Right, so a lot of us believe that he was referring to the Orion model being released this winter. O3 just got announced, release, so technically that's winter time, right? Is this Orion? Here's the thing, it's not. More on that later. But let's dive in. Now, this is the video that I did about O3 being released, saying this is AGI. And even in the comments, we have a lot of debate. Some people agree, some people disagree. As this user said, as an AGI myself, I can tell that this is not AGI. Certainly they would know. People point out it doesn't actually learn from the process, which more of that in just a second. That's a great point. The point is we don't have one clear consensus if it's AGI or not, right? The point is we don't all agree whether or not this is AGI. I just posted a poll asking, is AI currently smarter than the average human? And I explain exactly kind of like what I mean by that. I'll leave a link down below. Please vote. I'm curious what you think. Is AI currently, let's say the O3 model, is it smarter than the average human? Right? By smarter, I mean stuff that, you would expect your assistant to do, basic everyday office tasks, writing, basic math, planning, troubleshooting, problem solving, just the average job requirements for your average job. Right? Not rocket science, not engineering, just office work, let's say. So let's take a look really fast at what people are saying. So Adam D'Angelo, so he's the founder of Poe. He's, I believe, the co-founder of Quora back in the days. He is on OpenAI's board. He was one of the few people during the coup when Sam Altman was fired and came back 3 days later. He was one of the people that was on the board and stayed on the board after that whole thing happened. So he's saying it's wild that O3 results are public, and yet the market still isn't pricing in AGI. Notice Elon Musk responds, the markets claim to look ahead, but mostly look behind. AI will ultimately render money meaningless. And then they take shots at each other about the upcoming lawsuit, but we'll cover that in another video. Here's Francois Chollet. So he's the creator of ARC-AGI. So this is somebody that's a lot of us, myself included, look to kind of like make these tests that are able to, stump a lot of the large language models that just kind of memorize it to come up with something that really tests for general intelligence. They have done a phenomenal job. The current sort of ARC-AGI 1.0 stood the test of time for quite some time. And now they're already building the 2.0 version that's going to be even better at trying to kind of separate what's memorization, what's sort of like pre-training versus the AI's ability to generalize, right? So that's the kind of like the G in AGI, the general part of it, right? Because technically we already have super intelligence, artificial super intelligence. We do. It's just narrow, right? It's super intelligent at beating us at Go, at chess. Right? Those are superhuman level abilities. What we don't have is general intelligence, or at least this is what we're kind of beginning to debate. Is this sort of a human level general intelligence? As I'm scrolling through his tweets, so he shows this sort of exponential chart of, the various models, how well they've performed on the ARC-AGI, right? You see it kind of shooting upwards with, the O1, O3, the reasoning models. So Francois says, it's missing the stick man. Please add it to the chart. Do you get the reference? He's referencing wait, but why, right? This is the kind of, at this point, classic sort of human progress meme, right? So this idea that we're kind of here, and there's this sort of like exponential explosion in technology and abilities. This is talking about AI, right? And of course, if you're kind of standing at the base of that, it might feel pretty normal. But obviously, when you look here, it's anything but. That's literally what he's referring to. That's the chart. He's saying that should be that stick man here, kind of like unaware of this. Somebody did the overlay. And yes, it certainly seems eerily close, does it not? By the way, have a like, good sir. That was phenomenal. Phenomenal. But as some of you have pointed out, he said this. Is this AGI? While the new model is very impressive and represents a big milestone on the way towards AGI, I don't believe this is AGI. Now, a lot of people in the comments kind of said, well, if this person says it's not AGI, it's not AGI, or if this other person says it is AGI, it is AGI. The point is we don't have a test for AGI. We don't have one sort of a unified definition for it. So when we're talking about it, we might all be talking about different things. It's not if one person says it is or it's not, then that's what it must be. By the way, he should not say it is AGI. Here's why. He's got one of the sort of best benchmarks for tracking progress towards AGI. It's something that everyone's aware of. It's someone that everyone trusts. They have a phenomenal test, a great approach. People take the benchmark seriously. They shouldn't be calling it, right? They should be continue making, at this point, they're making ARC-AGI 2, right? Sort of version 2.0, which is going to be extremely challenging for the O3. And once some model easily cracks that, they should create, ARC-AGI 3, ARC-AGI 4. So that's kind of the point here. Like, we shouldn't have this us versus them. Is it AGI or not? It doesn't matter. Let's have a better definition for AGI. Then we can actually specifically determine if we're there or not. As far as Francois Chalet goes, him saying, hey, this is not AGI. Let's keep making ARC-AGI 2, 3, 4, 5. That he should be doing that. That's a public good that he's doing. It's tracking AGI progress. It's getting people interested. They should just keep this going as long as possible, because we're now slowly beginning to understand like what the models are good at, what they're not, where they're better than humans, where they're not. But here's one point that surprisingly, I think that a lot of people are missing. So here's Ethan Mollick, a sort of great person in the AI space, a professor, researcher, and he, I believe, was the first to come up with this concept of the jagged frontier. Also Centaurs and Cyborgs as it applies to AI, but that's for a different video. But I think this idea of the jagged frontier is very important to understanding AI and its abilities and its progress and whether or not we're at AGI or not. Here's what the jagged frontier is. So notice this kind of like a smooth curve right here, right? So this is kind of the things that we think of as tasks of equal difficulty, right? So imagine somebody in kindergarten, like they might have a curve that's right here, right? They might be able to, stack blocks and try to tie their shoes and whatever tasks kids can do at that age that are of equal difficulty. We sort of expect all of them or most of them to be able to do it. Then you might have a high school student, right? Writing an essay, taking geometry or calculus or whatever, maybe doing some sort of basic chemistry and physics, right? So these are sort of all what we perceive to be equal difficulty tasks, right? Then you might have some PhD level person up there. They might have some much more advanced tasks, but if they can do one thing, you kind of expect them to do this other thing, right? Right. If somebody can fix a loose chain on the bike, you would think they'd be able to like put up a shelf on the wall, right? That might be a bad example, but the point is it's somewhat equal tasks in our mind, equal difficulty tasks. Here's the problem. AI, unfortunately, right now doesn't really work that way. It looks like this blue or purple line here, right? It's more jagged. You ask it to write code that simulates the behavior of black holes as you approach the event horizon or whatever. It's like, sure thing, boom, done, right? You ask it how many R's there are in strawberry. It's like, oh, that's just unknowable, right? It's that idea of jagged frontier, right? So there's things that humans would find extremely difficult that the AI just completely dominates. And there's things that we would find very, very simple that the AI just routinely fails. And this is what I think a lot of people are missing in their conversation about AI and its abilities. Like, let's say this is the curve for sort of your average human, their ability to do various things. Right here, you might have their ability to do math. Here, it's various language things. This is like visual reasoning. And maybe here you have code or some sort of logic-based problems, right? So we would expect like an average person to be at a certain level across all of these things, like, obviously. Now, obviously, different people will have different sort of abilities, but sort of on average, this is kind of the curve of the average human being. And of course, there's a million other little specific things all along the way, right? But let's say AI comes in and it's like incredible at math. It's, good at language. Maybe there's some specific things it fails here, right? It's not so good at vision and it's just incredible at code. And there's some other things that it fails here. I have no idea what I wrote here. Visual. I'm just going to put an eyeball like that. How about that? And let's make this even more pronounced here. So it's really bad at this particular thing. Counting R's in strawberry, for example. Here's the problem. Here's what I think a lot of people are kind of missing in this conversation. What I see very often is people will find this thing that the large language models are terrible at, right? They'll point to it and they'll say, well, obviously this thing isn't as smart as humans because look, this a child could do. And this model completely fails at it. Therefore, it's not as smart as humans. And certainly if this is the human ability and AI's ability is in general lower, and then maybe it's better at like calculating stuff or memorizing stuff, but in general, its abilities are lower than the average humans, we can kind of dismiss this and say, well, yeah, humans are on average smarter. And if it's just better across all tasks, then this is where I think everybody would say, okay, so this is obviously smarter than humans, right? Because it's better across every single thing. It's slightly better here, slightly better there. But here's the thing, it's not going to look like this, maybe ever. The real question is, like, what if the model fails at counting R's in strawberry and, fails some very basic trick questions where it's just like completely false for very basic trick questions, right? So it kind of fails at that. But the rest of it looks like that. And this is it's solving cancer. And here it's solved the Riemann's hypothesis, which a lot of people say is kind of like the big deal in math. I'm not 100% sure what exactly that means, but let's assume it's a big deal. And here it figured out how to do like unlimited, cheap, clean energy, whatever. So basically it's much smarter than our best scientists and engineers, etc. Right, so it has those kind of superhuman abilities, but it's still, you ask it how many R's there are in strawberry and it fails. It's like, I have no clue. It's unknowable. It's beyond our abilities. Like, are we still going to say it's not smarter than humans because like these jagged edges fall below what we expect humans to be able to do? Is that the way we judge intelligence? So in other words, like if AI's abilities are like this and this is humans, we would say, well, it's clearly not as smart as humans. And if its abilities are like this, we say, well, it's clearly smarter than humans. And there's no more arguments, right? But it's never going to look like that. It used to be like this, where it's mostly not as smart as humans. And then it got, some things better, like it would be able to figure out what a cat looks like, right? As good or better than a human. Maybe it would be able to like translate stuff better than a human. That was how it was, 5-10 years ago. But now it's getting to the point where it's like mostly much better than humans at most things. Right, but we always have some group of people that are pointing to these as examples of this AI being quote unquote dumb. Oh, this ant has 4 legs. Therefore, this video generation model is useless. Oh, it can't, count the number of letters in strawberry. Therefore, this large language model is useless. Oh, look, this person in this image has 6 fingers. Therefore, this AI image generation model is useless. Meanwhile, we had an AI-generated image win some prestigious award at an arts competition. That was submitted. I think they didn't tell them it was AI-generated. This was kind of early on in 2022 or 2023, something like that. So we're giving it awards already, right? Sora and all the other models, VO2 by Google. I mean, there's some implicit sort of understanding within those models about physics and 3D structures and kind of like these advanced incredible sort of mental models of, to generate the video. They need to understand how like lights work and how shadows work and how reflections work. You don't think about it, but if there's in a video a mirror, you have to have a reflection of something, which means you kind of have to understand what that thing looks like in 3D. So it's not just generating sort of 2D surfaces. It has some mental model in that latent space that kind of predicts what 3D objects look like, what they're going to look like from all sides. We've seen the O1 model write code that it took a PhD level physicist 1 year to write. It replicated within 20 minutes or so with a few sort of nudging prompts, but it did it, right? But people will find an example where they ask it a trick question about like a marble and it'll like not figure out where the marble is or how it's supposed to behave. And they're like, this model is useless because it failed this little trick question. So my question is, how insane are these curves going to get? How far past human ability are these things going to get until we realize that these little sort of things that it's bad at, that maybe doesn't disqualify it from being super intelligence or general intelligence or whatever you want to call that. So in other words, if it cures all forms of cancer, but it can't spell cancer backwards, is it smart? Or is it dumb? So big thanks to Ethan Mollick. I want to give him credit for kind of, as far as I know, coming up with this idea. Certainly this is where I first understood this concept, this idea of the jagged frontier. But it's an important concept to kind of keep thinking about, keep in the back of your mind as we talk about AGI, right? So as AI abilities get clearly superior to most humans in certain areas, but maybe fall behind in others, like, how do we define when it's sort of on average or in general better than humans? When does it have general intelligence? And my point here is that a lot of people, I think, are waiting for all these little vestiges, all these little sort of where it's slightly below human level, for all these things to cross the line. When there's no little nitpick mistake we can point out, then it's artificial general intelligence. But you got to kind of take into account this, right? These things where it's superior, right? How big do those get before we go, okay, it wins? By the way, here's Ethan Mollick's recent comment on the ARC-AGI debate and kind of the O1, O3 models and what they represent. So he says the ARC benchmarking debate is obscuring the fact that test time compute seems to be the real deal based on experiments with O1. O1 and Gemini 2 are precursors. O3 is likely better. And this is also kind of a big thing that a lot of people are just missing. If you recall, a few weeks ago, places like The Information, but also a lot of like the mainstream publications, basically all right around the same time started publishing articles saying, well, AI scaling has hit a wall. All researchers agree that AI progress will come to a stop and we've hit a wall, blah, blah, blah. Like it just started like coming out of nowhere across, all the publications, almost like as if they were like coordinating it. And if you've been following, as you know, like a lot of us were kind of skeptical of those claims. Like, really? You think it's going to slow down? And of course, since then, we've had the O1, the O3, and of course, we still have people that are not getting it. So here's the Wall Street Journal saying the next great leap in AI is behind schedule and crazy expensive. Again, this is what we're kind of seeing happening. To say that something's slowing down seems to be at odds with reality. Here's Jason Wei, an AI researcher at OpenAI. He's saying O3 is very performant. More importantly, progress from O1 to O3 was only 3 months, which shows how fast progress will be in the new paradigm of reinforcement learning on chain of thought to scale inference compute. Way faster than pre-training paradigm of a new model every 1 to 2 years. So for people that haven't been following this whole thing, so the new breakthrough is this idea of test time compute. The idea that we can sort of ask this model a question and then sort of spend more resources on having it think through the answer and generate a solution. So this is referred to as either test time compute, and sort of the idea of it thinking before answering is referred to. So I've seen it called chains of thought. So before these models came out, users have found that saying to the model, hey, think through step by step before answering. And the model would do so. It would think through everything and then finally come up with the answer. And the results were better. It tended to be better at reasoning. And so the sort of idea that made this approach so successful is they took those sort of chains of thought, as they refer to them as, and they sort of hid them, or at least put them in a different window. So the model would think about the answer sort of on a scratch piece of paper, its thoughts, right? And then based on those thoughts, on that reasoning, it would then answer. And so, of course, for every time it thought, it would generate words, it would generate tokens. And that costs some money, right? Every sort of token costs some money to produce. So this breakthrough was like, what if we simply gave it more resources, more time? We spent more money on giving it more time to think. And in fact, the 88% accuracy on the ARC-AGI that the O3 model showed, that was when they let it run for a very long time, allowed it to use billions of tokens, 5.7 billion tokens, if I remember correctly. And I think it cost something like 300 plus at sort of like a retail cost. If you and I were to run the model for that long, that's how much it would cost us. And of course, this is why the ARC-AGI, now they're talking about they've always had limits on how much compute you can use, but they've been talking about sort of also using that sort of cost metric or some sort of an efficiency metric, like adding that to the results, because that's yet another sort of KPI, sort of key performance indicator, right? So if a model spends millions of dollars coming up with an answer, I mean, it's good if it's super accurate, but it's also kind of not feasible to just spend that much money on it. So there are probably going to be limitations and a certain sort of like some efficiency metric that we're going to be tracking. And for example, for the competition, like they're shooting for about 10 cents per task as sort of the maximum amount of compute. And so this is kind of what Jason Wei is talking about, right? So this new paradigm of these chain of thought scale inference compute, that's what he's talking about. So we're scaling the inference time compute. So we ask it a question, we give it time to think, right? So that's inference, that's the answers, the inference, and compute is the hardware resources that we're using. So instead of just spending more money training the model, which maybe, yes, that's been slowing down a little bit because you have to have exponentially more data and more processing power to build exponentially bigger models. What we're saying here is like we're almost started scaling across a whole different like paradigm or different like just avenue of doing it, right? A new approach. And that is that test time compute. So using chains of thought to generate better reasoning before it answers. That's the same thing that Ethan Malik is saying, right? So that's a sort of debate of the ARC-AGI prize. Is this AGI? Did it really beat it? It's obscuring the fact that test time compute seems to be the real deal. It seems to be this brand new scaling avenue. Here's the information saying OpenAI wows the crowd as a new scaling law passes its first test. And interestingly, they also mentioned this. So they're talking about Jason Wei, an OpenAI researcher, the same person we just looked at. They're saying Wei may also be considering the fact that OpenAI hasn't made use of its next big pre-trained model, Orion, yet. Orion could serve as the base model for O4, or whatever OpenAI calls its next reasoning model early next year. It's not going to be O4 because calling it O4, here's the problem, it would make sense, and OpenAI does not name their models in a way that makes sense. If I had to guess, they'll probably name it LOL, but with ones instead of the L's, lowercase o, obviously, or something equally random. Meanwhile, the O3 model is better than 99.95% of programmers, of coders. ARC-AI and FrontierMath, this is the benchmark they developed for evaluating advanced mathematical reasoning in AI, right? So we're sort of running out of human-level difficult math problems, right? We need stronger math benchmarks. We're having a hard time coming up with extremely difficult problems for these AI models to solve. Here's Terence Tao, Fields medalist, saying these are extremely challenging. He's talking about the problems, the math problems on this benchmark. And he says, I think they will resist AIs for several years at least, right? That's the best that we can hope for, is to create problems challenging enough to where these AI models won't beat them for, a few years. Here's a sample problem testing Arden's primitive root conjecture. And some of these subjects that sort of are included here are number theory, density of primes, order of integers, modulo prime, Arden's conjecture, inclusion, exclusion principle. And the techniques that you would need to solve this are things like prime number theorem, density theorem, generalized Riemann hypothesis, asymptotic density, inclusion, exclusion principle. Obviously. But if that's too difficult, fear not, here's a low difficulty one. So this is the easy one, right? So you would need to know about finite fields, Hasse-Weil bound, finite field arithmetic, and some Python implementation. How many non-zero points are there on, this equation? There are words here I recognize. And so a lot of the current models have been struggling with this test, right? Gemini 1.5 Pro. So from the looks of it, they're all less than 2% accuracy. Claude 3.5 Sonnet, O1 Preview, O1 Mini, GPT-4o, Grok 2. Like under 2%, maybe 1%, closer to 0 for some of them. So the previous state-of-the-art model was 2%, right? 2.0. O3 out of the box, 25.2. So it's kind of important to understand that it's already, so the AIME 2024, so it's kind of like the best math human minds come together. I think that one is on a kind of a pre-college level, I believe. It's not the IMO, the International Mathematics Olympiad. This is the AIME. So, the O3 gets 96.7. So I think it missed one question. They said, we have humans that got, 100. But the point is, like, this sort of math test that we give to our best and brightest, it's already saturated. Like, this thing is maxing it out pretty much. We finally come up with that FrontierMath, the super, complicated, next level math questions. And we're like, all right, so we're able to hold back these AI models for a few years. They're only getting 1 or 2%, right? O3, boom, 25% accuracy. Now, by the way, so this is an example of a task that the O3, the high compute, right, $300,000 sort of test run of O3, it couldn't solve this problem. So you're sort of given the 3 examples, and then you're asked to solve this problem. So what would you guess the answer be? Now, I got to say, I'm very impressed with this question. And this is why I like the ARC-AGI benchmark so much. They really did a good job. And what's another interesting thing is that no set of problems kind of use the same sort of underlying trick or whatever. So if you solve this problem, you're not going to see another problem where this sort of type of solution also works, if that makes sense. So if you look at this, this might seem kind of overwhelming at first, but if you kind of take a second, it seems like it's almost, I'm thinking of it as like a video game, right? So this little block reaches out here and then whoop, moves there, right? This orange block reaches out here, whoop, moves there. So these sort of things sticking out, that's where it's moving to. It's almost like it's grasping something and holding itself there. So that means this light blue goes here, this blue goes here, orange goes here. O3 was not able to solve this one. But here's the thing, and I gotta like look into this a little bit more, but here's the thing, if I understand correctly, this is what the model is given, right? So they're not using sort of a vision to understand this. This is the problem, right? So you have tests, you have the inputs and the outputs. So you have these sort of matrices. I'm guessing they have some sort of a code for what these numbers mean. So 7 is light blue and 6 is dark blue, whatever. And so you have like inputs and outputs. Actually, out of curiosity, I threw a screenshot of 2 of those test problems and I said, based on these 2 sample problems, what do you think is the way that these shapes are transformed? And this is the ChatGPT o1 Pro model that we're using here. And I'll try the same thing with just the entire puzzle, just to give it 2 different sort of variations and see if it's able to visually maybe do it better. So this is what it says, not quite. So it's saying the shape is squared off into its bounding box, not quite. So the reason I'm showing this is because like this is an example of a simple ARC-AGI tasks that, has the 3 training pairs, right? So here are the sort of the 3 training pairs. There are 4 colors represented by the integers 1, 4, 6, and 8. And so this is how the AI model is seeing these questions, not the colorful sort of blocks that we're seeing. So I've tested the o1 Pro mode, the vision, its ability to understand those questions, and it doesn't do well, which is expected. The vision isn't quite as good as sort of the language yet. So that's why they're using this sort of JSON format to train it and to get the outputs. But I think the big point here is this, like whether you would call this AGI or not, again, we don't have a specific definition. I think the ARC-AGI people should continue coming up with harder and harder tests that try to sort of separate the sort of the general intelligence from some sort of a memorization. We don't really need to announce AGI necessarily. We just need to kind of like keep improving the benchmarks and keep testing it, keep having this forward progress. Because keep in mind, all the people, the founders of ARC-AGI, none of them are saying that this is nothing. All of them are saying that this is a big leap forward. But whatever the case is, whether you agree with me or not, can we at least agree that this is AGI-ish? Can we agree that something really incredible is happening here and that scaling didn't slow down? In fact, we just got sort of a new avenue, a new approach to scale and improve these models. And also, here's a question for you. Assume that this improvement continues and these models get better at coding and math and writing and just every single benchmark is either saturated or we have to create brand new ones and it keeps climbing those ranks. But at the end of the day, it still can't solve something as simple as this, right? Because this is, not super complicated because like visually, once you see it, once you get it, it's pretty straightforward. But my question, if it's out there doing stuff that no human can even approach in terms of math and coding and all these other wonderful things, if it's like superhuman across many different frontiers of science, but it can't count the number of R's in strawberry, or it can't figure out this puzzle. To you, does that mean that it's not AGI, that it's not superintelligence? Meaning that if there's one thing that most humans can do, something like this, and it can't, does that mean that we sort of discount everything else that it does? Let me know in the comments. I'm curious to know what you think. With that said, my name is Wes Roth, and I'll see you next time.